solving two-step equations. A two-step equation is something that has two operations in it. If you look at this one here, 3n plus 8 equals 29. There's two things happening to the variable. It's being multiplied by 3 and added by 8. If this one over here, y is being divided by 8, and 15 is being subtracted from it. So with this, we're going to see how it is you go about when there's more than one thing to do to isolate the variable. I hope you know by now that the ultimate goal when solving any equation is to isolate the variable. How you're going to do that, you're going to undo what's happening to the variable. Addition and subtraction undo each other. Multiplication and division undo each other. And yes, I want you to write it down again. So pause the video and write it down again. So the question is, which operation do you undo first? If you'll remember when we did solving equations with integers, I kind of gave you a basis for just solving equations in general on that, first or second slide. You're going to work the order of operations backwards. It's read SADMIP instead of PEMDAS. You're going to undo either the subtraction or the division first. I'm sorry, the subtraction or the addition first, then the division or the multiplication, then exponents, then parentheses, and like I said then, you're not going to see equations with exponents and parentheses in 7th grade. That will come in 8th grade Algebra 1 and beyond. So looking at this equation, 2n plus 5 equals 13. Which one do we undo first? I look for either subtraction or addition. 5 is being added, and as we've learned from previous lessons, you undo adding 5 by subtracting 5 on both sides. Don't get lazy on me and just write it on one side. Write it on both sides because otherwise it's not a true statement. You have to follow those properties of equality. 5 minus 5 is 0. So those end up canceling. And 2n comes down. Then 13 minus 5 is 8. And then I reevaluate it again. N is being multiplied by 2. So I'm going to undo multiplying by 2 by dividing by 2 on both sides. It cancels on the left here. 8 divided by 2 is 4. So n equals 4. Then the check is going to come in. And I have this in a thought bubble because ideally you can do this in your head. If you're not really good with mental math, then you're going to want to write this out. But this is the beauty of solving equations. After you find the solution, you can check to see if you did it right. Plug it back into the original equation. So I've put 4 in red here because that's what I think the solution is. I've put it in the place of where n was in the original equation. 2 times 4 plus 5. I'm going to see if that's equal to 13. Multiply first. 2 times 4 is 8. And then I add 8 and 5 and I get 13. So it checks out. That is a true sentence. So let's try these examples. Negative 3p minus 8 equals 19. I'm going to start by undoing the subtraction. So I'm going to add 8 on both sides. Cancels there. So negative 3p comes down. Do not forget that negative in front of the 3. It hasn't went anywhere. That equals 19 plus 8 is 27. I'm going to reevaluate it then. P is being multiplied by 3. I'm going to undo that by dividing by negative 3 on both sides. Cancels here. So P equals 27 divided by negative 3 is negative 9. I'm going to check this in my head. Negative 3 times negative 9 minus 8. I'm going to see if that equals 19. Negative 3 times negative 9 is positive 27. And then 27 minus 8 is 19. So that checks out. Coming over to the second one, I have 24 equals x over 10 plus 32. X is being divided and x is being added to. I'm going to undo the adding first by subtracting 32 on both sides. 24 minus 32. I'm taking away more than what I started with, so my answer is going to be a negative. You could think of that with subtracting if you still want to do the keep, change, change. Keep, change, change. Ideally, you're starting to be able to do these in your head. You're not having to write out the keep, change, change every time, but if you are, that's okay. I have a positive and I have a negative that I'm adding. They have different signs, so I'm going to take the difference. The difference between 32 and 24 is 8. There's more negatives, so it is a negative 8. That's going to equal x over 10. And 32 minus 32 cancels. Reevaluated. X is being divided by 10. I'm going to undo that by multiplying by 10 on both sides. 10 times negative 8 is negative 80. And those 10s cancel. So negative 80 equals x. I'm going to check that out by substituting negative 80 into the original equation. Negative 80 over 10 plus 32, and we're going to see if that's equal to 24. Negative 80 divided by 10 is negative 8. Negative 8 plus 32, they have different signs, so I take the difference between them, which is 24, and there's more positives, and it checks out. Pause the video, try these out, and then compare with what I come up with. Okay, on practice 8, it's 8 plus m over 4 equals 17. I'm going to undo adding 8 by subtracting 8 on both sides. 8 minus 8 cancels. So m over 4 comes down. 17 minus 8 is 9. Next, I saw that m is being divided by 4, so I multiply by 4 on both sides. It causes those two to cancel. M comes down, and 9 times 4 is 36. Then check that in your head. Put 36 back in here. 36 divided by 4 is 9. 9 plus 8 is 17. That makes sense. Coming over to this one. This one looks pretty ugly. It might have scared you a little bit. We're going to undo adding a half by subtracting a half on both sides. And remembering our adding fraction rules, we have to get the common denominator, which is what I've done in blue right here. 1/2 is equivalent to 7 over 14. That's a common denominator. Now I'm going to subtract 5 minus 7, which gives me negative 2. So if you might look at it like that is what came down. R over 7 equals negative 2 over 14. I'm going to undo dividing by 4 on both sides by dividing by 7 by multiplying by 7 on both sides. And to multiply by that whole number, I put it over 1. Negative 2 times 7 is 14. 14 times 1 is 14. It cancels on the left. R comes down, and negative 14 over 14 is negative 1. Yeah, there you go.